Good day! So welcome sa next topic natin, which is integration by parts. So this is another technique of integration, similar dun sa integration by substitution. Now, before we continue, gusto ko lang i-reiterate bakit puro techniques lang yung dinidiscuss natin. So recall, yung paghanap ng derivative, yung process ng differentiation, meron tayong method sa kanya, yung limit ng difference quotient. So, the functions na gusto nating makuha yung derivative nila, i-apply lang natin dun sa functions na yun, yung difference quotient, and all the shortcuts or theorems that we use to find the derivatives of common functions, nanggagaling sila sa observations natin after we applied the limit of the difference quotient. Now, for integrals, wala tayong isang process that we could apply, which is why, in general, we say that integration is more difficult than differentiation because we don't have a given process. And what we've been doing so far is we're taking advantage of functions and expressions na familiar sa atin as derivatives. At hinahanap natin yung function na pag kinuha mo yung derivative ng function yun, makukuha mo yung given natin. So medyo dependent tayo sa familiarity, sa results ng differentiation because we don't have a process for finding the integral of a function similar dun sa process na paghanap natin ng derivative niya. And in a way, yung technique ng integration by parts, it relies on the result that is given to us by differentiation pa rin. So si integration by parts, it relies on the result of the product rule of differentiation. So simulan natin by trying to recall what is the product rule of differentiation. So let's say we have two functions, f and g, pareho silang differentiable. Let u be equal to f and let v be equal to g. The product rule tells us that if you want to find the derivative of u times v, this is u times the derivative of v plus v times the derivative of u. Now, ang gagawin natin ay i-manipulate natin tong equation na ito such that i-isolate natin si u times the derivative of v, yung kulay dilaw. So we could write it as u times the derivative of v. That will be equal to the derivative of u times v, yung product natin kanina, minus v times the derivative of u. Now we've since moved on to treating dx as a value rather than just yung d over dx as an operation. We could manipulate this by cancelling out lahat ng dx dun sa expression. So magkakaroon lang tayo ng u dv is equal to duv minus v du. And the presence of all those differentials should give you a hint kung ano yung gagawin natin next. And that would be to take the antiderivative of both sides of the equation. Then we'll have the integral of u dv equal to the integral of duv minus the integral of v du. Now, what can we do with these expressions? We cannot evaluate this yet, the integral of u dv, kasi magkaiba yung variables natin na u at yung dv. We cannot evaluate this as well because iba yung v sa du. So let's look at the middle expression, yung first term ng right-hand side, the integral of duv. Since we're treating uv as a single expression, the integral of duv will just give us uv. This will be our formula for integration by parts. The integral of u dv is equal to u times v minus the integral of v du. Let's keep in mind that here u and v are differentiable functions. And this will be our formula for integration by parts. Note that hindi ito yung kabaliktaran ng product rule of differentiation. Ginamit lang natin yung result ng product rule of differentiation para makagawa ng isang formula for integration by parts na pwede nating gamitin to evaluate some types of functions. So ang mga magiging given natin ay in the form na nasa left, yung integral of u times dv. The challenge here is to be able to break apart yung given sa atin na expression into two parts, isang u, isang dv. Now, the whole idea of doing this integration by parts is that we are given usually a complicated integral. And our goal is to express that given integral into another integral na mas madaling ma-evaluate. So, ang objective natin ay mabiyak itong integral of u dv para magkaroon lang tayo ng integral of v du that is relatively easier to evaluate compared kay u dv mismo. I know na baka mahirap pa siyang ma-imagine kasi we haven't seen any examples yet, But yung challenge natin sa lesson na to ay yung paghanap ng tamang u na pwede nating gamitin para ma-come up yung right-hand side nitong formula at mabigyan tayo ng bagong integral na mas madaling ma-evaluate. So what we generally want is to choose a u na madaling i-differentiate. Bakit? Kasi pag nahanap natin yung u, ang kailangan natin ay du dun sa bagong integral. And a dv that is relatively easy to integrate. Bakit? Kasi ang kailangan naman natin dun sa bagong formula ay yung expression na v. So, in converting from the integral to u dv, si u, ang destination niya ay maging du, si dv, ang kanyang goal, ang kanyang objective ay maging si v. Kaya gusto natin ng dv na madaling ma-integrate at u na madaling ma-differentiate. So, let's move the formula sa taas and let's take a look at an example that will hopefully illuminate kung ano yung gusto nating mangyari. So, we want to evaluate the antiderivative of x times e to the x. So, let's move over dun sa solution for this problem. Okay, so this is our example, the integral of x times e to the x. So, what are our choices for u tsaka dv? Start tayo dun. Okay, one of the first choices we have is yung u natin, the first function, could be x. So, lahat nung matitira, pag pinili mo na yung u, kasi pinili mo na u is equal to x, everything that's left, yung e raised to x times dx, that will have to be dv. Now, let's remember our formula for integration by parts. Kailangan natin ng du at kailangan natin ng v. So, what will we do with these two values? Well, we need to find du by taking the derivative of u equals x. So, du must be equal to dx. Kasi ang derivative na x, 1 and du over dx equal to 1, so du is equal to dx. Next, we need to find the value of v. You can do that by taking the antiderivative of e raised to x, yung dv natin, e raised to x dx, and that's just equal to e raised to x. So now we're ready to use our formula. So yung balik tayo sa given, the integral of x times e raised to x, this will be equal to yung formula natin sa integration by parts, u times v minus integral of v du. But what is u? What is v? Na-solve na natin siya, so i-substitute na natin yung values na yun. uv is equal to x times e raised to x minus the integral of v du. But v is equal to e raised to x and du is equal to dx. So this is our next step. Lagyan lang natin ng plus c1 for good measure para hindi natin makalimutan. Although baka hindi naman strictly kailangan kasi hindi pa natin na-evaluate yung antiderivative. But I just put it there. Next, we evaluate yung integral of e raised to x. That's just equal to e raised to x. So our given will now be equal to x times e raised to x minus e raised to x plus our constant of integration. We have nothing further to do, so let's highlight our final answer. So yung next question natin ngayon ay paano kung iba yung pinili nating functions for u tsaka for dv. Now let's try what will happen kung iba yung pipiliin natin. So in our second case, ang pipiliin kong u ay e raised to x. So everything that is left, yung x tsaka yung dx, that will have to be dv. Now again, according sa formula natin sa integration by parts, kailangan ko ng du at kailangan ko ng v. Si u naman madaling i-differentiate, so du is equal to e raised to x dx. Si v din naman madaling i-integrate, so we could write v is equal to 1/2 x squared, yung integral ng x. Then we apply our formula for integration by parts, so this should be equal to uv minus integral of v du, and u times v is equal to 1/2 x squared e raised to x minus the integral of 1/2 x squared e raised to x dx. But let's take a look at this integral. Ano ba yung objective natin? Gusto natin na yung lalabas na integral of v du after nating i-apply yung formula ay mas madaling i-integrate kaysa dun sa given natin sa integral of u dv. Taking a look at the new integral, yung exponent ng x tumaas pa. So in fact, this is a more difficult or a more complicated integral compared dun sa given natin. This means that it might not have been a good choice of u. Kasi hindi tayo pumupunta sa mas simple. So let's say pinili mo na, well, u equals 1 and everything else is dv. U equals 1, dv equals everything else, which is yung x times e raised to x dx. Now, kailangan ko ng v. And that means I have to take the integral of dv. But if I do that, I'll just be taking the integral of x times e raised to x dx. That is the original given. So parang walang point na ginawa nating dv yung everything else, tas ikukunin natin yung integral niya, di bumalik lang tayo sa gusto nating mangyari. Isa pa, if you look for du will be equal to 0. Kasi du over dx is equal to 0. So, that's a non-starter, no? Okay, so wala tayong pupuntahan doon. I guess one more choice that we could make is that u is everything. X times e raised to x. And dv will just be yung dx na matitira. If we use these values, kukunin natin yung v, madali lang, integral ng dx will just be x. But if we take the derivative of u, kaya naman natin, but we'll have to use the product rule. So that will be x times derivative of e raised to x plus e raised to x times the derivative of x. So we'll get du is equal to x times e raised to x plus e raised to x, quantity times dx. And we apply the formula for the integration by parts, and we'll get our uv is equal to x squared times e raised to x minus integral of v du, which is the integral of x squared times e raised to x plus x times e raised to x, quantity dx. So, distribute natin yung x dun sa dalawang terms na nandun sa du. Now, take a look at our new integral. It is still more complicated than our given. And one thing that you should note, no, is yung given natin na integral na x times e raised to x. Lalabas siya dun sa second term ng integral na to pag dinistribute natin yung integral symbol. It's even more complicated than our given, and there's no point in continuing with this approach. So it turns out that the first choices that we've made for u is the correct one. Kasi siya yung nakapagbigay sa atin ng integral na mas simple kesa dun sa given. So as you can see here, it's really important na makadecide tayo dun sa u na gagamitin natin. Kung ano yung best na possible u that we can use that will give us an answer quickly. Fortunately, meron naman tayong guide kung paano tayo pipili ng ating u sa mga functions na kailangan nating gamitan ng integration by parts. So let me introduce you to this mnemonic, LIATE. It's a mnemonic device to help you choose your u, and then everything else na matira, siya na yung magiging dv natin doon sa integration by parts formula. This mnemonic device, yung LIATE, it stands for L for logarithmic, I for inverse trig, A for algebraic functions, T for trigonometric functions, and huling-huli nating pipiliin yung exponential na function. So ito yung pagpili ng u. Now this may not always work, no? But in general, ito yung best choices natin to start with. So in our next set of videos, kung saan tayo magdi-discuss ng more examples, we'll use this as a guide in making our choices for the best value of u. So I hope to see you dun sa examples videos natin, and for now, salamat sa pakikinig.